Question 47. This is the last 4 story problems. It says, for 47, you've got a buoy in the ocean is observed from the top of a 40-meter high radar tower on shore. So if you drew this, here's your tower. It's your tower, and here's your little buoy in the water, and the tower measures 40 feet. And then it says the angle of depression. The angle of depression, so from the top of it would be this angle right here. That's your angle of depression, and it's 6.5. So if this is 6.5, you could get this angle easy by doing 90 minus 6.5. And you get 83.5. Now, if you don't want to use this angle, because they're asking you how far, they want this. How far is the buoy from the tower? They want this measured. Do you need to figure this out? Not really. You could use, you learned in geometry that 2 parallel lines cut by a transversal, alternate interior angles are congruent. So we know that even though this is your angle of depression, this is also 6.5 degrees from geometry. So how could you use, if you want to use your 6.5 and not have to subtract, or you can use that number or you can use this number. But I would use what trig function to find this side in reference to this angle, and you know that. Anyone? Tangent of 6.5 is equal to the side opposite over the adjacent. Now, if you used this angle, it would be tangent of 83.5 equals x over 40. So either way, you're going to either multiply these two, or you're going to do 40 divided by tangent of 65. Either way, your answer is, anyone have it? 51.1. And then that would be in meters, because the question is in meters. Got it? Okay, the next one. A man is standing 12 feet from a statue. So I'm going to draw, here's the man. He's standing 12 feet from a statue. There's the statue. So from here to here is 12 feet. It says the angle of elevation from eye level, here's his eye, to here, to the top of the statue. This angle, you always do angle of elevation, it's always measured from the horizontal, so straight across. So this angle of elevation is 30 degrees right here. And then it says the angle of depression to the bottom of the statue is 15 degrees. We want to know, how tall is this statue? So we know that this is 12 right here. You've got 2 little triangles right here. So what you're going to do is figure out how big that is, how big this is, and then add these up to figure out how tall the statue is. Does that make sense? So what trig ratio will you use with 30, 12, and this to get x? Anyone? You have 30 degrees right here, and then you have the side opposite and the adjacent. That would be tangent. So tangent of 30 is equal to the side opposite over the adjacent. Cross multiply, and you get 6.393. Now to find this bottom part of the statue, you're going to do the same thing, tangent. Tangent of 15 is equal to the side opposite over the adjacent, and you're going to get y is equal to 3.22, and if you add these two up, 6.93 plus 3.22 is about 10.15 feet. You have to add these two up. Okay?
Is some of this gonna be on our test?
No. It's just ACT stuff. Whatever's on the 6 tests and the Kaplan, that's on the test. Number 51, a rocket shoots straight up from a launch pad. So here's your rocket. It's shooting up from a launch pad. 5 seconds after liftoff, an observer, here's your observer, and the observer is 2 miles away. Notices that the rocket's angle of elevation is 3.5. So this is what you do. So this is 3.5 degrees. Then 4 seconds after that, the angle of elevation is 41 degrees. So the rocket keeps going up. And the angle of elevation, so from here to here now, is 41 degrees. They want to know how far did the rocket rise during those 4 seconds. So they want this measurement. So what you're going to do is you're going to figure out what this measurement is using this triangle, the 3.5 and the 2 miles. And then you're going to figure out the big triangle, which is 41 degrees and 2 miles. You're going to figure out this, and then subtract these to get that, how far it went up. So is everyone with me on that? So let's do the small one. We'll call this x. So you're using 3.5, it'd be tangent of 3.5 is equal to x over 2. Cross multiply, and you get 0.122. Then the big, call y. This, actually that's not what I meant, this is y. We'll call this whole thing y. So the angle is 41 degrees and this is 2 miles. So again, tangent of 41 is y over 2. And you should get, when you cross multiply, you get 1.739. And when you subtract these two numbers, you're going to do y minus x to figure out how far it went after that 4 seconds. It'd be 1.6. You're subtracting these two numbers. And the last one. In aerial navigation, directions are given in degrees clockwise from north, called headings. So this would be 90 degrees east. 180 would be this, from here to here. So what would 270 be? This would be 270. So 300 degrees is this angle right here. That's 300 degrees. From here to here is 300 degrees. They want to know how far west, this is west, this would be north. So this would be from the airport, this would be west, call that W, and that would be north. So the plane, it says that it went 200 miles. So this is, your hypotenuse is 200. So can you tell me what this angle is? We see a little triangle right here. I need this angle. I know that this is 200. That would be north, and that would be west. What's this, how do you figure out this angle right here? If from here to here is 90, and this is 90, and this is 90, what's that? What's 3 of these? 270. Well, from here to here is 300 degrees. So 300 degree angle. From here to here. All the way around would be 360. So if you do 300 degrees minus 270, because that's what these are 270, that angle is, this is 30 degrees. So if they're asking you for strictly how far west, I would use cosine. Cosine of 30 is equal to side adjacent over 200, and when you cross multiply, you get 173.21. Now if I wanted to know how far north the plane was, I would use sine. I would use sine of 30 is equal to north over 200, they didn't ask that, but if they did, you would use sign. They asked west. Anybody have any questions on these? Okay, we're done.